Okay, so in this video, I'm gonna provide you with 3 examples of using dummy variables in a regression model, and my emphasis will be on the interpretation of the model. In the first example, I'm gonna use wage 1 data. So we have wage, education level, experience, tenure, and some other characteristics of different individuals in this data set. As we can see that we have represented female as a dummy variable, which shows whether a person is female or not. So this variable will take the value of 1 whenever a person will be female. So both person 1 and person 2 are female because this variable is showing you values of 1 in both cases. Person 3 is not a female. That's why this variable is taking the value of 0 in this case. In this first example, we want to estimate gender wage gap. So we can have a look at the table of this female dummy variable, and we see that in the sample about 274 people are male and 252 people are female. So our data is well split between these two categories. Here I'm going to regress wages in level on this female dummy variable, and then I'm going to include education, experience, and tenure as control variables in the model. So this coefficient value on female, remember it is delta 0 from our previous discussion. This delta 0 measures the impact of being a female on the wages. So this coefficient shows the average difference in hourly wages between a man and a woman. So according to these results, we can draw ceteris paribus interpretations that holding tenured, experience, and education constant, female on average earn $1.81 less than their male counterpart. That is, if we pick two individuals with same level of education, experience, and tenure, female will be making $1.81 less than man with the same level of education, experience, and tenure. Also note that this variable is statistically significant with a t-value of minus 6.83, and we can easily test a one-sided hypothesis that whether this coefficient value is statistically significant or not on the lower end, which in this case is statistically significant at the lower end. So our results indicate the existence of a gender wage gap, which is not only economically significant but statistically significant as well. In the next example, we are interested in knowing the effect of computer ownership on college GPA. And we have this PC dummy variable in the model, which takes the value of 1 when a student owns a computer and 0 otherwise. And this is the distribution of students with a personal computer, 56 of them, and students without a personal computer, and there are 85 of them in our model. And we are interested in knowing whether giving students computer has any impact on their performance, that is, whether their GPA goes up by owning a computer or not. According to these results, if a student owns a personal computer, their predicted GPA will be 0.16 points higher than a comparable student without a personal computer. Also note that this effect is statistically significant at about 1%. In this third example, we want to measure the impact of a grant on hours of training that firms provide to their employees. And in this case, our dummy variable is grant, which takes the value of 1 for the firms get this grant and 0 otherwise. So we're going to look at the table and see that 61 firms got this grant and about 405 firms do not get this grant. I'm going to regress this model using data only for 1988, and that is my subset that I'm going to use in this regression model. So looking at the result, we are interested in the variable grant, which shows the difference in the hours of training that the firms provide to their employees based on whether the firms got this grant or not. This dummy variable shows that controlling for the level of sales and number of employees, firms who got the grant provided 26.25 hours more training as compared with the firms who do not get this grant. So also make sure that you interpret this coefficient right, because we have to interpret this coefficient in relation with the omitted category And in this case, that is the firms, those do not get this grant. Again, this effect is 26.25 hours of more training for the firms who got that grant as compared with the firms who do not get this grant. And this effect is statistically significant as well. So this is how you interpret these dummy variables. In the next couple of examples, I'm gonna introduce you to models where we have our dependent variable in the log form, and then we'll see what will be the interpretation of these dummy variables. All right, I'll see you in the next video. Bye-bye.